Solving simultaneous equations graphically. In today's lesson, we will be looking at solving simultaneous equations graphically. So simultaneous equations are where there are two or more unknown equations, and then you obviously have to work out the identical unknown values. So they can be solved algebraically or graphically. In today's lesson, we will be looking at working them out graphically. So I'm going to put up two equations first. We're going to have a look at y equals 3x plus 8, and we are going to look at y equals 6x minus 1. And we have to solve these graphically. So the unknown values here are y and x. We want to know what y is and what the value of x is. So we have to do it simultaneous, means together. They're linked, these equations are linked together. So let's see if we can work this out. First of all, we need to draw ourselves a table of x and y values. Sometimes this is given for you in the exam, sometimes it's not. Okay, I'm going to do one that's 0, 1, 2, 3, and 4. It's the same here, 0, 1, 2, 3, and 4. Okay, right, let's have a look then at the values that we're going to have. The first one, y equals 3x plus 8. So to work out y, I've got to do 3 times x plus 8. Well, if my x is 0, 3 times 0 is 0, plus 8 is 8. Next one, when x is 1, 3 times 1 is 3, plus 8 is 11. Next one, when x is 2, 3 times 2 is 6. 6 add 8 is 14, and you can already see a pattern. What's the pattern between these numbers? Well, get a different color pen. You can see that's adding 3. That's adding 3. That's because the gradient of your line is 3, so the difference will be 3. So the next number, when x is 3, is going to be 17, and the next number is going to add 3 on, is going to be 20. Let's just double check that. 3 times 3 is 9. 9 add 8 is 17. For 4, 3 times 4 is 12. 12 add 8 is 20. Okay, the next one then. When x is 0, what's y? So 6 times 0 is 0. Subtract 1 is minus 1. When x is 1, 6 times 1 is 6. Subtract 1 is 5. Next one, when x is 2, 6 times 2 is 12. Subtract 2 is 11. Next one, now again, let's just have a look. What's the difference between this? 6, isn't it? Difference is 6, so we can work out the next one without substituting. That's 17. And the next one, I'm going to just have to add 6 on because the difference is 6, the gradient 6, and there we are. So we've now got to plot this. Okay, I've done the first few here already. Okay. We've now got to plot this on this graph. So let's plot the first line. We'll do it in different color pen because that'll make your life a lot easier. So the first coordinate is 0, 8. So 0, 8 is here. Next coordinate 1, 11. Next one 2, 14. Next one 3, 17. Oops. Try and follow this. Oops. Okay. Now I'm going to get my pen. I think that's right. Is that 317? I don't think it is it? No, I think that's right. That's okay. Let's double check. That's 1, 2, 3. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, that's okay. Sometimes it can be slightly hard doing this on a computer screen. Okay. Okay, for some reason, my line is not adding up. And I feel like it's because my number 3 is not in the right place. But it is. Okay. Well, let's just try and draw this as best we can then. Okay. It's not right, is it? Probably like this, isn't it? Yeah, probably like that, the first one. The second one was incorrect, so let's get rid of that. And do it like this. Okay, nib of my pen, and because it's on a computer screen, is slightly incorrect, right? I'm going to label that as y equals 3x plus 8. Okay, next one, do it in a different color pen. I'm going to do it in blue. When x is 0 minus 1 is there. Next one, 1, 5. There. Next line, 2, 11. Try and follow this if I can. And next one, 3, 17. And you can also kind of already see what's going to happen. Okay, it's easier to do this on paper when you have a pen. And doing this is quite hard to try and move this around. Oopsie. On a computer screen to try and get it. I'm just going to do it like this if I can. There we are, kind of there. We did it kind of, just slightly off. And the answer to your question is where the two lines intersect and where they meet. So here you can see they meet here. If I highlight it, that is your answer. Okay, so x equals, so what's the coordinate of x? It's 3, isn't it? And y equals 17. And that is your answer. Okay. Right. Lovely. Okay. Right. Let's have a look at a few other examples then, like this. Put the ruler away, we don't need that. Okay. Y equals 3x minus 1 and y equals 2x, right? Again, we have to draw our table of values first. So I'm going to have y equals 3x minus 1. Okay, I'm just going to fill in this in, the 0, that's 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, that's going to be 1, 2, 3, 4, 5, 6. That's going to be minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6, okay? So I'm going to just do x here and y here. I'm just going to do a few numbers. To make it easy, I'm just going to do positive 0, 1, 2, 3, and 4. Okay, so again, when x is 0, what's y? 3 times 0 is 0, minus 1 is minus 1. When x is 1, 3 times 1 is 3. 3 take away 1 is 2. Okay, next one, when x is 2, 3 times 2 is 6. 6 subtract 1 is 5. And we can see here clearly that the numbers that they're going in are up in 3s because the gradient is 3. So we can guess the next one by doing 5 add 3, which is 8, and then 8 add 3, which is 11. Okay, the next one, y equals 2x. So again, I'm just going to do x and y. Again, the same number, 0, 1, 2, 3, and 4. So to work out y, I've just got to do 2 times x. So times the x is by 2. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. And 4 times 2 is 8. I'm going to plot the coordinates for y equals 3x minus 1 on my graph. So 0 minus 1, 1, 2, 2, 5. And I can't plot the other one, 3, 8, and 4, 11, because it's off my axes. Okay, I'm just going to join that up. A line if I can. Remember, it might be slightly better for you on a paper. Right, plot y equals 2x. So what I'm going to do first is I'm just going to write it down. Oops, get rid of the ruler. Okay, always label your line for the examiner so they can see what's what. Next one, y equals 2x. So 0, 0, 1, 2, 2, 4, and that's it. Okay, I'm just gonna, if I can, try my very best to go through all the points if I can. Something like this. Okay, get rid of that, and I'm going to label that as y equals 2x. And you can see here that the graph intersects at this point. So my x value and my y value is x is 1 and y is 2. Okay, and we can check this because we can substitute the value in. So here, if we do x is 1 and y is 2, I've got 2 equals, well, 3 times 1 is 3, take away 1. 2 is equal to, well, 3 take 1 is 2. That's correct. The values are right. I can do the same there. Y is 2. If x is 1, 2 times 1 is 2. That is correct, and you can check your answer in this way. Okay, let's do another example then. Similar to this one, then we'll make it slightly tricky. Y equals 2x minus 1. So I'm going to just start by doing 0, 1, 2, 3, 4, 5, minus 1. Oh, sometimes messes up. Let's start that again. Minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, x and y values. I'm going to do 0, 1, 2, 3, and just 4 for now. When x is 0, what's y? I've got to times the x by 2 and then subtract 1. So 2 times 0 is 0, subtract 1, minus 1. 2 times 1 is 1, subtract 1 is 0. And we can see already here that the number is increasing by 2 because the gradient's 2, so we can just add 2 on. The next one, 2 add 2 is 4, 6. Okay, let's plot this graph. I'm going to do it in red. 0 minus 1, 1, 0, 2, 2, 3, 4, and I'm going to leave it at that. Try with my pen. You can see here it just isn't really, it's slightly bit hard to kind of get in the right place. Okay, kind of just do it like that if I can. Okay, just kind of missed that point there. The next one, I'm going to do y equals, so let's do it in green. Y equals x. That is pretty simple and straightforward, isn't it? 0, 1, 2, 3, 4. So whatever x is, y is going to be the same. 0, 1, 2, 3, 4. Get rid of the ruler. So 0, 0, 1, 1, 2, 2, and you can already see 3, 3, and 4, 4, where it's going to intersect, can't you? It's important in the exam that your line is actually accurate. Oops, there we are. And extend the lines like I'm doing, okay? You don't just draw the line where the few points that you've plotted, you've got to extend the line, okay? So label my, that's y equals x. That was y equals 2x minus 1. The intersect here, so x is 2 and y is 2, okay? Right, let's have a look at another example then. This time we have got x minus y equals 3 and x plus y equals 5. Okay, so slightly different and slightly trickier. So normally you are used to seeing questions which are in, or the equations which are in the form y equals mx plus c. Yeah, that's different. That's not y equals. These are x minus y equals 3 and x plus y equals 5. Now, there are two different ways of doing this. You can either draw your table of values and work it out this way, or you could rearrange. I always rearrange because I find it easier. So number one, we've got x minus y equals 3. I want to make it y equals, first of all, that's a minus y. So I'm going to make that positive by adding y on both sides. It's like the balancing method. Just left with x on this side because minus y add y is nothing. That's 3 add y. I want it to be just y equals, so I need to get rid of this 3. Subtract 3 on both sides. So I'm left with x minus 3 equals y because 3 take 3 is nothing. And I can rewrite that as y equals x minus 3. Right, when I have that, I can then draw my table. Before that, I'm just going to label this 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, 0, 1, 2, 3, and 4. Okay, when x is 0, what's y? So 0 take away 3 is minus 3. 1 take away 3 is minus 2. 2 take away 3 minus 1. You can see the number in front of the x, invisible number, is going to be 1. So it's just going up in ones. So the next one's going to be 0 and 1. plot the graph. 0 minus 3, 1 minus 2, 2 minus 1, 3, 0, and 4, 1. And I'm just going to try my very best, kind of. Okay, it just gets a little bit funny when it's like this. Okay, get rid of the ruler, label that as Y. Oh, you can label it as any because it's the same, but I'm just going to label it as what the question said. Right, the next question. This one here, we are going to rearrange. So I have got x plus y equals 5. I want it y equals, so I'm just going to get rid of this x here. The y is positive, so I don't need to do anything with it. Minus x minus x. I'm left with x take x is nothing. Y equals 5 minus x. I can now draw my table. X and y, again, just do the same. 0, 1, 2, 3, 4. Okay, when x is 0, what's y? So this is what I'm looking at. I've got to do 5 minus x to get y. So 5 minus 0, 5. 5 minus 1, 4. 5 minus 2, 3. And look, what's the number in front of the x? It's minus 1, isn't it? Because then minus belongs to the x. And the invisible number in front of x is 1. So it's minus x, so you're subtracting 1 each time. And you can see that. 5 take 1 is 4. 4 take 1 is 3. The next one's 2. Next one's 1. Let's plot the points then. 0, 5, 1, 4, 2, 3, 3, 2, and 4, 1. Get your ruler. Okay, and draw your line. Label your line. So I'm going to label it what the examiner or the first question said it was. You can see it intersects there. So we're going to say x is 4 and y is 1. Okay, now just a little pointer. In the exam, if the question says solve algebraically, you cannot draw the graphs and solve the simultaneous equations because the examiner is asking you to use algebra. However, if in the exam it doesn't ask you, you are allowed to use graphs. So it's entirely up to you. Sometimes you do get a graphical question as it is and the graphs are drawn for you, or you have to draw the graph as it is. Okay, so that's that. Let's quickly do another example then, last one before we go. So again, I've got x plus y equals minus 5. Rearrange that. I just need to get rid of x. So x take x is nothing, left with y here. 5 minus x, oh, the same as the other one. So x and y, I've got 0, 1, 2, 3, 4. I'm just going to label this 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, 5 take away 0 is 5. Then it's 4, 3, 2, 1, same as the other one. So 0, 5, 1, 4, 2, 3, 3, 2, 4, 1. I'm just going to get that and I'm going to draw that out. And I've got, this one was x plus y equals 5. Draw the graph of y equals 4x, so x and y. 0, 1, 2, 3, 4. So to get y, I've got to times my x by 4. So 0 times 4 is 0. 4 times 1 is 4. 2 times 4, 8. 3 times 4, 12. I'm going to leave it as that. I'm going to draw this in red. 0, 0. 1, 4. And 2, 8 doesn't fit on my graph. So no point even trying to plot that. Try and aim this if I can. Kind of something like this. Extend the line. That line is y equals 4x. And it's where the graphs meet, where they intersect. So I can say x is 1 and y is 4. And we have solved the simultaneous equations graphically. So that was today's lesson on solving equations or solving simultaneous equations graphically. These were linear sequences and we've solved them graphically. Hope this lesson was useful for you. Thank you for watching.